continue with section 5.5, and here is something a little bit different than what we just saw. So here we are going to use something called a inverse function property. So if you recall, I think I don't remember if I did an example like that in 2.8 or not, but let's do it here. So this is a property of inverse functions, that if you take a composition of a function with its inverse function, you will always get back the domain value. Okay. So for example, if you have f of x is equal to, so let's just pick any function. So I'm going to pick cube root of x plus 2, and we are going to find the inverse function of this function. So how do we find the inverse? Remember, we change the f of x into y, so we have y equal to cube root of x plus 2. Now in order to okay, I think I do it like this. At this place I will switch x and y. So I get x equal to cube root of y plus 2. Okay. And now our job is to find y, or isolate the y. So in order to do that, the first step would be to undo the cube root. And how do we undo the cube root? We will take the cube on both sides. So I will get x cubed equals y plus 2. So that y will be equal to x cubed minus 2, and this is our f inverse of x. Okay, so now let's try to find what we get if I do f inverse composed with f of x. So this will be f inverse of f of x. So which means in the f inverse function, in here I will place my f of x function. So I get, so I cube x cube, right? So x is replaced by that quantity, and then we have a negative 2 from here. Now the cube will cancel the cube root, so we end up getting x plus 2 here, and then we have minus 2. So if I do just get rid of the brackets, parentheses, so we end up getting x. Now you should try do the other one. So you should try to do f of f composed with f inverse of x, and you will notice that you end up getting x. So this is the property of the inverse function, but for that the important thing is that the x should be in the domain of the function which is on the right in the composition. So in this case, the x should be in the domain of f inverse of x, and in the one that I did, x must be in the domain of f. So following these properties, following this property, we have the similar properties for these inverse trig functions. So we have that if you compose the sine of with sine inverse function, so we can write it as sine of sine inverse of x, then it will give us x if x is in the interval -1 to 1. And why is that? Because remember, the sine inverse function has the domain of sine inverse is -1 to 1. Now the other way, we have sine inverse of sine of x is equal to x. So in this case, now the domain of sine x as itself is all real numbers. Remember, the sine curve goes on and on and on forever, but here we are thinking about the restricted sign. So the domain of the restricted sign function is negative pi over 2 to pi over 2. So as long as x is a value in this interval, we can just cancel the sine and the sine inverse, and we get our x. Same thing is happening for the cosine and then for the tangent. Okay, so let's see how we can do these examples. So first one is saying find the exact value of each expression. So here this is sine inverse. The domain of sine inverse is, remember, negative 1 to 1. So what we have to do is, this is our kind of our x. So does this fall in our domain? So is 3 over square root of 10 inside negative 1 and 1? How will you find it? Well, this is a positive value, so it will be on the, somewhere between 0 and 1, right? So it should be between 0 and 1. Only then we can find. If it is not, then we will say it does not exist. So how do you find this value without a calculator? So you have to estimate, or you have to find an approximate value. So how will you check that? Well, note here that square root of 9 is equal to 3. So square root of 10 will be equal to 3 point something, 3.2 something, or I don't even care what it is. Just I want to know that square root of 10 is greater than 3. So that if 3 is being divided by a number which is greater than 3, the answer will be less than 1. So this number is between 0 and 1, which is okay. So therefore the answer to this question will be, or this expression will be 3 over square root of 10. Looking at the next value, cosine of cosine inverse of 1 7. Okay, 1 over 7 we know is less than 1. So yes, the answer will be 1 over 7 by that property of inverse functions. Then we have tangent inverse of 4. Now the domain of the tangent inverse is negative infinity to infinity. So any number here will give us back that number. Okay? Looking at next one, so it's a sine of sine inverse of 5. Now 5 is a number which is bigger than 1. So this does not exist, or this is not defined. So we can say not defined, or we can say DNE, which means does not exist. Next is cosine of arc cosine of 7 over 2. Now 7 over 2 is 3.5. So 7 over 2 is bigger than 1. So this one does not exist. Next, sine of sine inverse of negative 8 over 9. So 8 is smaller than 9, or 9 is more than 8. So 8 over 9 will be less than 1. So in other words, 8 over 9 will be, negative 8 over 9 will be more to the right of negative 1. So this number will be on the interval, or on the line negative 1 to 1. So this number looks like it will be somewhere here. So it is in the interval. So the value, or the answer to this will be negative 8 over 9. Okay, now looking at them from the other side, now notice that the inverse function is outside now, and the actual function, a restricted function is in the inside. So tangent inverse of tangent of negative pi over 3. So remember that for the restricted domain of the tangent, we have the restricted domain that minus pi over 2 to pi over 2 with n points not included. and negative pi over 3 is inside this interval. Again, it's easier to look at it this way because we are looking here and the negative pi over 3 lives here. So we get back our negative pi over 3. Now if you forgot, if you say, oh, I forgot the domain of that tangent, you can also do it in another way. Okay, I'll show you after I finish this. So next one is arc sine of negative pi over 6. So negative pi over 6 is within our domain of sine x, which is from negative pi over 2 to pi over 2. So the answer will be negative pi over 6. Next one, cosine inverse of cosine of 3 pi over 4. Now for the cosine, the range is from 0 to pi, and 3 pi over 4 is inside that, so the answer will be just 3 pi over 4. Now next is slightly different because now we have not the same composition of an inverse function with a normal function, but not the same. So how will we do that? And that the way that you will do that the same way you could do these ones as well. Okay, not this one yet, but in chapter 6 I think you will learn how to do them in another way if you forgot that this property of the, because it could be that when you have to apply this property that sine and sine inverse cancel each other, you have to keep make sure that the number in front is within the domain, and if you forget that, then you will get a wrong answer. So in this case, what we do is we first evaluate this. We find what is tangent of 3 pi over 4. Okay, how do we do that? We first locate where does the 3 pi over 4 live on the circle, on the unit circle. So remember, if I divide this into each quadrant into halves, this is pi over 4, this will be 2 pi over 4, which is pi over 2, this is 3 pi over 4, so this is our value. Now here the tangent will be negative because the coordinates of the terminal point will be negative square root of 2 over 2 comma negative positive square root of 2 over 2. So the tangent will be negative 1. Okay, so we are now saying, so this will be sine inverse of negative 1. But what is sine inverse of negative 1? We did it a little while ago. So this is negative pi over 2. So note here that it didn't give us 3 pi over 4 back, and the reason is because 3 pi over 4 is not in the domain of the tangent. Again, looking at the next one, so cosine inverse of sine of pi over 6. Now pi over 6 is not in the domain of sine, of the restricted sign. So we have to just figure out what is cosine of sine of pi over 6. The sine of pi over 6, remember 5 pi over 6 is in the second quadrant, and the sign is positive there, so the value will be the same as whatever is sine pi over 6, which is 1/2. So we end up getting cosine inverse of 1/2. But now, what is cosine inverse of 1/2? This will be equal to pi over 3. Okay, now we came back to cosine. So cosine inverse of cosine of negative pi over 3. So is negative pi over 3 in the domain of the cosine? Remember, for cosine we restricted our domain from 0 to pi. So if you look at it this way, from here to here, and this angle which we given here lies in the 4th quadrant, so which means it is not inside in the domain of the cosine, restricted cosine. So we cannot just say that the answer is going to be negative pi over 3. We have to evaluate it. Okay, so how do I evaluate it? Well, I say okay, cosine of negative pi over 3, so negative pi over 3 is over here, so it will be the same as the pi over 3, because remember the x coordinate of these two will be positive. So this will be equal to cosine inverse of 1/2. So cosine inverse of 1/2 is pi over 3. So the answer will be pi over 3. Okay. So next, this one, secant. Now we are looking at the other trig functions which we have had forgotten. Okay, good. Now we are looking at secant of 17 pi over 6. In order to find this, we should first find what or evaluate cosine of 7 pi over 6. So we will look at what is cosine of 17 pi over 6. So how do we do that? Well, this is a number which is much bigger than 2 pi. So what you will do here is you will divide the 17 by 6. So notice here, what do we get? 17, well 17, 6 3s are 18, so they cannot go 3 times, it has to go 2 times. So 6 2s are 12, and then we are left with 5. So that the 17 over, because remember this 17 pi over 6 can be written as 17 over 6 pi. But now 17 over 6 can be written as, by this division, I can write it as 2 plus 5 over 6, and in parentheses pi. But now this, when I distribute, this will be 2 times pi plus 5 pi over 6, or 5 over 6 pi. So you saw in section 5.3 and 5.4 that the cosine is a periodic function with a period of 2 pi. What does that mean? It means after every 2 pi, a multiple of 2 pi, means after completing the whole square, if I get to a value whose coordinates or terminal point we know, then cosine will have the same value as it is for that coordinate in the first initial angle. So that cosine of 17 pi over 6 will be the same as cosine of 5 pi over 6. Okay, because the 2 pi we can just it will kind of go away. Okay? And then 5 pi over 6 cosine will be negative, and the pi over 6 cosine is square root of 3 over 2. So we can negative square root of 3 over 2. That will be our value for the number 8. Now looking at this is number 13. So now looking at number 14 now. So we will do, by the way, sorry, my bad. So we finished finding the cosine, but we were supposed to find secant. So secant of 17 pi over 6 will be equal to negative 2 over square root of 3, or rationalize it. So you get negative 2 into square root of 3 over 3. Now looking at the next one, this is cosecant of 13 pi over 3. Now cosecant is 1 over sine, so I have to find sine of 13 pi over 3, okay, and then we will invert it. So notice here again 13 pi over 3 can be written as, so go on a side, on a like a scrap paper or on the side of the problem here, scrap work, and then you divide 13 by 3. So 13 4s are 12, 1 carried, so you can write it as 4 plus 1 over 3. So that 13 pi over 3 will be equal to 4 plus 1 over 3, so that 13 over 3 pi will be equal to 4 plus 1 over 3 into pi, or 4 pi plus pi over 3, which means that sine of 13 pi over 4, so 13 pi over 3 will be the same as sine of pi over 3. And what is sine of pi over 3? That is square root of 3 over 2. So what will be the cosecant of pi over 13 pi over 3? That will be 1 over this value, because cosecant is 1 over sine of this angle, so we get square root of 3 over 2, or 2 over square root of 3, which can be rationalized like before, and we end up getting 2 into square root of 3 over 3. Looking at this last one now, cosine of tangent inverse of negative 1. Now, tangent inverse of negative 1, if you recall, we have it that it is equal to negative pi over 4. So we end up getting cosine of this one, cosine of negative pi over 4. And what is cosine of negative pi over 4? It will be square root of 2 over 2. So some of these are pretty quick or simple, but the others involve a little bit of work. So this is how you deal with these inverse functions. This is the end of chapter 5. Now we will move on to chapter 6 in the next video.